This is my attempt on the physics cart on a slope question. So to go into that, I have to first go over what my process is before we go into the more complicated stuff. So as the professor has previously said, the goal in doing physics problems is to make the problem as simple as you possibly can. This will just make your life easier, and who wants to do more work than they have to? So in the question where it's a cart moving at a constant speed, it shoots a ball straight up and then the ball lanes back down. We can make this problem really simple by completely removing the x-axis, right? We can turn a two-dimensional problem into a one-dimensional problem. So one way to think of this is if you had a chase cam, right, following the cart at the exact same speed, it wouldn't be able to tell that either the ball or the cart was moving in the x direction, right? It could only tell their y position. So that makes the problem a lot easier to deal with. So here's a non-complete, of course, a list of ways that we can use different reference frames or different axes to make a question easier. We can tilt axes, which is what I'm going to use in the following example. So what this means is instead of x and y being like this, they're like this. So one of the reasons that we have x and y like this is because usually gravity is acting straight down, right? But if your acceleration is not caused by gravity or not caused completely by gravity, it might make sense to align your axes with that acceleration. Just make your life a whole lot easier. Another thing that I'm sure everybody's used is having a convenient origin. So having 0, 0 at a position that just makes the math really easy to do. You could also have a moving axis, like in the previous question. You could have an accelerating axis if you want to. Or anything else that comes to mind as a frame of reference. If it makes your life easier, do it. So let's see how we can apply this knowledge to the cart on a slope example. So let's make the x-axis be along the slope, and then that means that the y-axis is perpendicular to that. So I made x plus be this way and x plus be along the slope. Just a preference thing. So let's draw out all the forces acting on the cart. So we've got normal force, we've got gravitational force. Both of those are vectors. But because you can split any vector into two component vectors at a 90-degree angle, I can make gx and gy, right? Gx and gy. What this allows me to do is to cancel out normal force and gy because of how normal force works. That's the same, which leaves me with only gx. So that's really convenient to deal with. Now, that doesn't solve the problem quite yet, so let's go to the forces acting on the ball. So because it's in free fall, the only force acting on it is gravity. But let's split that vector into two component vectors. So I have gy and gx, same as before. What immediately pops out to me is that gx and gx are the exact same, right? Gx equals gx. So relative to the x-axis, the ball and the cart will always have the same position. It could fall way past the cart, like fall off the side of the track, and it would still have the same x position. It could be shot almost into space and it would still have the same position. It's a really convenient thing to have.